Okay everybody, so it's Friday, it's about noon, and this is where the helicopter's at. I've got one battery attached. We're going to power it up for the first time. This is going to be full 6S power. Motors. Wires go in the ends. Coaxial quadcopter, so it's 4 arms, 8 motors. Here's our electronics. Do a focus. You can see this is the power wire. Oops. That's the power wiring for the flight control board. And we've got power tap for that's coming up from the wiring harness through a grommet for a little protection. Okay, so that just plugs in over on the side here. That's power for the flight controller. This board on top, this is called an I2C isolator board. And what it does is it breaks up that one stream of I2C data, which is all of your motor control information, and it breaks it up into individual plugs so you can wire up the ESCs individually. This was made by AGL Hobbies, that's Rusty's shop, and he discontinued it, probably because with the old microcopter stuff, people weren't using it very often. But I've used it once before, it works great. I really like the thought that a motor controller, a BL in microcopter speak, can be swapped out individually with a minimal amount of work compared to the power board being buried at the bottom of the stack. So microcopter has an I2C distribution board, the Mini 8 they call it. So I couldn't get one in time. I knew of one of these that was available. My friend Mike down in Houston, Emo Wilcox, he sent it up to me. I knew he had it sitting in one of his parts bins in his shop, so that's worked out really well. Over here, this is called a Spectrum diversity board, and what it does is it connects to the flight control board and it allows you to use multiple satellites, JR Spectrum satellites. I don't know if this is in focus. I keep trying to refocus it. There we go. So what this does is it allows you to run up to 4 satellites. And it doesn't improve range, but what it does do is it improves reception because it's going to monitor the 4 satellite streams and pick the strongest one and then send that through a wire into the flight control board. So there's no receiver with this. Pretty similar to the systems that are using S-Bus or a PPM stream. It just uses the satellites. They're not plugged in yet, but anyway. And then we have this, which is a little speaker. Microcopter uses this to tell you various things about the flight control, and it's not very loud. It's really only effective on the ground, but it tells you the mode that the flight controller is flying in, you know, which parameter set it's using. It tells you some basic things on the ground. If you try to enable GPS without satellite lock, it'll have a slow beep. If your battery's low, it has a real fast beep. So there's a few. It's useful for some things, not very useful though. You're better off having telemetry if you really want to know what's going on in the helicopter, because in that case, the telemetry offers you a lot of information. Especially, I might as well show it to you now real quick, but especially, where is it? If you're using something like this, which is an XB system. This one's from 3D Robotics. So what'll happen is this, I wasn't really planning on getting into this, but I might as well. This plugs into the side of the nav board. It's an 8-prong, I believe, or 10-prong plug. It has 4 wires. And what this does, it transmits to this, which plugs into your computer, and you could actually run the full MK Tool system while you're flying and monitor most all of the parameters of the helicopter. And then you can also use this when you're doing waypoint flying, and it will transmit the position of the helicopter and overlay it on a Google map. So the telemetry option is really complete with this if you choose to use it. If you don't choose to use it, then you've got this, which I can't get focus on. There it is. Anyway, alright, so let's power it up. I'm going to put this in a tripod. This was supposed to be a short video. We're at 5 minutes already, which means it's going to take an hour and a half to upload. All right, you're going to hear the individual motors chirping. That's the startup test. You're going to hear the flight control board beeping. It's going to count 6 beeps to tell me that it senses 6-cell battery power. And then it's going to start beeping because it doesn't have a receiver. So that's going to be a warning message. No radio connection. Okay, so here we go. 6S power to the microcopter stack. Ah! So that's the full startup. Now it should start beeping because there's no receiver. This little board is freaking out because there's no radio reception. But if it's not beeping, that's fine. It might just be a configuration thing that has to get set up in MK Tool. And I'll take care of that before I fly it. There's still a bunch of configuration stuff I have to do on the computer. But that's it. It survived. This is how microcopter is. These motor controllers, the BLs, the flight control board that's down here, if it survives the first full voltage power up, then you're generally in pretty good shape. And after the first flight, if there's no issues, chances are you've successfully set it up and it's going to work well for a pretty long time. Most of the problems with microcopter when you set it up, most of the problems will appear right up front. And then once you work through them, or you survive them, or you don't give up, it turns out to be a very reliable, really well-mannered flight control system. Okay, so that's it. I'm going to work on finishing up all the little tidbits, get it ready to fly, and it's either going to fly after dinner tonight, before the Cub Scout meeting, or first thing tomorrow morning. And I've got about an hour's worth of work left, and then we're going to unbox the Movi, the gimbal, and work on getting that set up and tuned with a camera. And we'll be moving right along, okay? Trying to make it to Monday morning on site. Thanks for watching. Bye-bye.